My name is Don Pinto, and I'm a product manager at Couchbase. So the agenda of my talk today is mainly to kind of tell you guys how you can secure your Couchbase server stack in production. So mainly around utilizing the features that we have in Couchbase, things that you can do outside Couchbase at your infrastructure level to kind of secure your infrastructure on which Couchbase server runs. And if many of you are deploying, for example, Couchbase server on the cloud, such as on Amazon EC2, things that you can do on the cloud as well. So before I go into the next few slides, maybe a quick show of hands of how many of you are administrators and are responsible for securing your Couchbase server deployments? Okay, fair number. How many of you are developers responsible for building secure apps? Cool. So I think we got a good mix of audience, and I think the takeaways from today's talk that I want you to take away at a high level are tips and tricks that you can use to secure your Couchbase server in production. So before that, why NoSQL security? So NoSQL security is a popular solution for big data apps. And what do I mean by big data apps here? So big data apps are apps that process large number of amounts of unstructured data. And these apps process data coming in with a high volume, that's lots and lots of unstructured data. And just look at the world around us. We have emails and tweets and posts and web clicks and so forth. There's large amounts of unstructured data there. There's also data which comes in at a high velocity. So this data arrives into Couchbase server at a high throughput, at a high speed. And there's also different types of variety of this big data that Couchbase server is able to store. But the most important, I think, attribute of big data is the value of your big data. And your information that you store in Couchbase server is valuable. So what if you don't care about security? So definitely, in this case, you have data breaches where an attacker, for example, in the outside network can get access to the data. You may also have attackers within your organization who are not intended to access the data, who may get access to the data. And so this study is from Verizon's 2014 report on data breaches. And you can see that the study was done with over 95 countries, 50 organizations, over 1,300 data breaches. And servers, in the study of over 5 years, servers continues to be topping the list in terms of the component where data security breaches occur. Other than data security breaches, just the components, I told you that servers being the more popular component, data breaches are also costly. So in terms of data breaches, an average cost of a data breach, and this is as per the Poneman report in 2014, the cost of a data breach is about $5.85 million for an organization, and this is averaged over 9 years. The lost business, this is post the data breach. It's the reputation of your business is costly at the rate of, say, $3.32 million. So just summing up these two numbers, that's close to $10 million worth of losses just because of a data breach. So what are some of the key business drivers around security? So the first one is regulatory compliance. So I'm sure many of you work for organizations where maintaining regulatory compliance or adhering with regulatory compliance policies is mandatory. And what do I mean by regulatory compliance policies here? It's PCI, HIPAA, EU, ISO, and even more. Many of you may also work in organizations where a CSO, for example, within an organization may mandate certain security requirements. So security requirements around network access protection, identity management, patch protection, and all those things, right? There's even data consolidation and global outsourcing. So today that many of us use the cloud, many of us may take data and consolidate databases in the cloud. And one concern that a lot of folks may have there is who has the access to this data in the cloud, and what if you outsource, for example, an administrative operation? Who does a third-party administrator who's administering the database for you have access to the data in the cloud? So data security is important, and those all concerns exist. So the common questions from the field around data security and the common concerns in a typical Couchbase setup are as follows. So you may have thoughts about which ports are open through a firewall. What vulnerabilities exist? Is there any attacker? Is there any user that's getting access to sensitive data or through any app which is not intended to do so? Is there admin access and data separation access? Is sensitive data encrypted on disk? Is XDCR secure? Are backups encrypted? Is your data encrypted in the cloud? Or what if an operator steals the disk? And these are only some of the questions in your environment. There are many more. The bottom line is you need data to be protected in depth. So what do I mean by that? So this is the defense in depth strategy. That's not something new, and it has been around all the time from when castles were built. So when castles were built, you had the gates of the castles, you had the walls of the castles, you had watchtowers where people used to stand there and protect who comes and or gets around the perimeter of the castle. Similarly, if you map this to our infrastructure world, it's like protecting the network, protecting the storage, servers, VMs, OS, as well as protecting your core asset, which is your data. In this case, your data is stored in the basement of the castle. And here, if you translate it to the infrastructure world, that is protecting your data stored in Couchbase and as well as your app. So what you're going to learn in this presentation is some of the best practices of how you're going to secure your Couchbase server infrastructure and some of the features that we have today in Couchbase server that you can use to secure your Couchbase deployments. So we'll start with going and understanding what you can do outside Couchbase server first. So perimeter security is very important, and what perimeter security offers is a physical separation between the end user and the backend. Typically, that's accomplished through multiple layers of firewalls. So as you can see here, is you have the web and mobile apps, which your end users may access, but also get accessed by hackers who are trying to use your app to kind of get access to the data. The requests coming from the outside world typically go through an external firewall and are then served by a load balancer. So if you're an IT admin, if you're an app developer, there are a couple of things you can do at the load balancer level. And things like packet filtering, things like blocking malicious IPs are things that you can do at the load balancer level. Once the load balancer services the request, these requests are then forwarded to the web server. Right? So at the web server, there are a couple of things that you can do as well. So you can ensure that your external firewall is punctured so that you only allow ingress and outgress ports of the web server to flow through the external firewall. Then there's things you can do at the internal network level. So note that there is a second level of firewall here. So there's the internal firewall. So if you're an IT admin or a DBA, and you may deploy Couchbase server behind an internal firewall, there are things that you may do at the second firewall level, like allowing only Couchbase ingress and outgress ports to be accessible through the internal firewall. So note that the first firewall allows only certain level of ports open. The second firewall allows again, only Couchbase server ports open through the firewall. So what are typically the ports you might want to consider looking at? So with Couchbase server, you can accomplish this at your network level by configuring Linux IP tables. So this is very simple. It's available at sysconfig IP tables. And what the snippet shows here is how to kind of set up your IP tables rules so that you only allow port 80 and port 443 through the external firewall. Then there's Couchbase server ports. This is the second level of firewalling. And in the second level of firewall, there are a couple of important ports you may want to think about here. There's a list of Couchbase server ports that Couchbase server uses, and you may want to open or close the respective number of ports at the second firewall level. And definitely, for added security, you use IPsec on your local network.
Excuse me.
Yeah.
You say node to client, it's really client to node.
Which one? Sorry.
Directionality is important.
Yes.
So it's client to node, not node to client.
That's correct. So the rules are set up in such a way that you first of all you need to analyze your traffic going in and out of the firewall and only open those ports for that traffic which goes into the firewall or outside of the firewall. There are a couple of other things you can do at the host machine level, right? So with Couchbase, one of the things to remember is Couchbase executes as the Couchbase user on Linux. And there are some important files that Couchbase accesses as a part of its normal data access. So these are the data and the index files on disk, which are at this path. There's the password files, which are also stored on disk, which are in these paths. And also there's the tools folder, which you have administrator tools like backup, restore, as well as maybe the password tool for resetting a Couchbase admin password. So that's the path where you have the tools, and you may need to basically just make sure that you ACL this tools folder so that only the users that you intend to access that folder have access to the folder. By default, the Couchbase user is set up in such a way that that particular user is ACLed to that particular folder. In addition to that, what some of the things you might want to do from an admin perspective is just disable web console access. So what you can do for that is disable port 8091 or the SSL port of Couchbase, or only allow Couchbase admins to access the Couchbase infrastructure from specific machines. So what do I mean by the latter statement that access Couchbase only from specific machines? So this is a typical setup. Like let's say we have a data center in Seattle, and this data center has the Couchbase server cluster. But to access the Couchbase server cluster here, we have a setup of a jump box, and the jump box is configured with OS logging. So the premise here is only users, if the user or if the admin has to access Couchbase server to administer the cluster, he or she has to log into the jump box and then only can get access to the Couchbase server cluster. And since we have OS logging turned on at the OS level, whenever, like, let's say there's a failed login for a particular administrator, that's kind of tracked in the OS log on that particular jump box. There are also things that you can do to encrypt data at rest with Couchbase. So to encrypt data at rest, specifically the files that we talked about on disk, I'm excited to announce our partnership with Warmetric. So Warmetric offers a solution for Couchbase that allows you to transparently encrypt your files on disk. This solution also scales and grows with your needs based on your deployment. It is a policy-based system, and it's also tested with Couchbase. So if you guys are interested to learn more about this technology, stay tuned for the session after the session, where Derek will talk a little bit on how Warmetric and Couchbase work together. So that's kind of completing of some of the things that you can do outside Couchbase server. So let's look at next of things you can do inside Couchbase server. So let's start with password management. So Couchbase has many passwords. You have the admin password, you have the bucket password, you have the XDCR password for Couchbase. But one of the best practice regarding passwords that you can think about is to use strong passwords. And strong password, the definition of strong passwords, although I've kind of crafted a definition here, it depends on your internal organization requirements. So each of your orgs may have, for example, a requirement of what do you consider to be a strong password. So make sure when you do set up Couchbase, you do set up a bucket password or an XDCR password that you use strong passwords in Couchbase. You also have to make sure that you rotate your passwords periodically based on your organizational requirements. And later on, we'll see, for example, when you're setting up secure cross-data center replication, how you can just regenerate, for example, a certificate and basically rotate that certificate periodically. And finally, yes, we do get cases where there is an admin who might have forgotten his or her password, and we have a tool called CB reset_password, and this tool, when you run this tool, it basically is able to reset the admin password for Couchbase.
Is that new 3.0?
It is new in 3.0, yes. Pardon me?
It doesn't defeat the purpose of actually, like we're talking about the password, and now you have a tool, so somebody who get into the box can reset the password.
That's correct. That's a good question. So this particular tool is kept in the tools folder, and you need to make sure that if you, again, it's about the layer of security that you maintain at the tools folder. Ensure that you ACL that particular tools folder, so only folks who are required to get access. Yes, but if your machine is compromised, you basically are compromising the entire the data stored in that machine. That's correct. But however, you can use on-disk encryption facilities there. So even if, for example, if you use our technology with Warmetric, you can ensure that those data files on disk are encrypted, so the attacker won't get access to those data files. The next place where passwords are used in Couchbase is the bucket password. So buckets are logical containers for your documents in Couchbase, and buckets can be protected in Couchbase using a Ssl password. And authentication for these buckets happens over a challenge response protocol called CRAM-MD5. It's very easy to set up a bucket password in Couchbase. Again, just remember, use strong passwords. And when you create a bucket, you will be given this UI where you can set the bucket password in Couchbase. You can also edit an existing bucket, for example, to set that particular Ssl password so that you can protect that bucket. And whenever you need, whenever apps need to read and write from the bucket, you will need to provide the app with that Ssl password. A couple of things to keep in mind here. There are a couple of buckets which are created by Couchbase, or you might be created as a part of the installation process. For example, the default bucket. The default bucket in Couchbase has no password support. So you wouldn't get this UI for the default bucket. So one thing to keep in mind is in production, you might want to, for example, drop the default bucket so that folks cannot just get access to it. There is also sample buckets that you may have created as a part of the installation process. We have the beer sample, the game sim sample. By default, these buckets are created without any password. So either delete these buckets in production, or make sure that if you want to use them, you want to set a Ssl password so that anyone who gets access to these buckets needs a password to get into it.
So if you put the password on the bucket, it means you have to configure a replication to use that password.
That's correct. So your application will then need the password to be able to get access to do read and write access to that bucket.
And it is possible to use the existing toolkit or old
This is for Couchbase buckets. So for Couchbase buckets, when you do select your buckets, you'll be given an option of memcached buckets versus Couchbase buckets. This applies to just Couchbase buckets, where when you do that, you will be able to get.
client side Java, let's say you have a Java client application.
Mm-hmm.
When you talk to, you can specify the password before making any query.
Correct. So when you set up a connection, any client connection, you will be able to specify a password when you create that connection object, and so that that connection object knows that you're connecting to this bucket, and this is the password for that bucket.
Is there any cost extra? Like it will be a request, or it will be like when the connection to
It is for each connection. So I didn't get your question. Is it?
So is it every request you make to the Couchbase, or it's a different? Like you make a connection in the beginning when you start the application, at that time it does authentication, or it's every request?
At the connection time. Yeah. Okay, so the next thing is about read-only admin users. So this is a feature that we added in 2.2 version of Couchbase. And what you can do with the read-only admin user is you can set up credentials in Couchbase, the username, password, for a read-only admin user. And what are some of the privileges this read-only admin user has is he or she can view a couple of things without any edit capabilities. So things like cluster and bucket summaries, design documents, XDCR replication, events and settings. It's like a read-only view of your cluster without any kind of operations, without any ability to change any settings inside Couchbase. Another important feature that we added in 3.0 version of Couchbase Server is the Couchbase Access Log. So this is an exciting feature. So what it does is it tracks administrator access to Couchbase. So whenever an administrator, for example, logs into Couchbase, this access log monitors admin accesses either coming through REST or the admin console. So this is where the file is located, where this kind of the logging information is kept. The log format is the common log format, and there are some interesting things that you can do on this log file. For example, as you can see in the snippet below, we have the client IP addresses, so you can basically search for interesting client IP patterns, suspicious client IP patterns. There is also the error code. In this case, it is 200, but there may be other error codes that the system may return. So you may want to grep for the other error codes. There's also suspicious get URLs. In this case, it is accessing the default pools, but there may be other URLs that an attacker may try to access, which is also logged. So if you combine this logging that Couchbase has with the OS logging that we saw previously, you'll be able to get a better picture on who has logged into the jump box, because now you have the OS audit from the jump box, and then you also have the Couchbase Access Log, which is able to tell you whether an administrator who logged on the jump box connected to Couchbase Server or failed a connection to Couchbase Server. The next feature that we added in 3.0 is encrypted admin access. So this is for administrators who are administering Couchbase Server over the internet. So things like where you would connect to the admin console, typically you may require that the admin console be protected over an HTTPS connection. So this is a new port, 18091, and this port basically enables you to connect to the admin console over SSL. The Couchbase Server SSL port is enabled by default, right? So as long as you hit this URL, you'll be able to talk over SSL to the admin console. There's also this ability to view data over SSL. So by connecting to this 18092 port, you can now access your view data over SSL. And you may have requirements where you only want to force an SSL connection for a particular Couchbase server cluster. And the way you may want to do that is consider locking down non-SSL ports, like port 8091 and 8092. So what are some of the best practices you can do inside your app? So we talked about what you can do at the infrastructure level. We talked about some of the features that you can use within Couchbase. What are some of the things that you can do within your app? So it's not uncommon for people to, for example, deploy, let's say, a lib Couchbase application, let's say a PHP client, and run thousands and thousands of PHP processes. And each of these processes making a REST connection, let's say, to Couchbase server. Typically, you would also see that the cluster topology doesn't change frequently. So you have many short-lived lib Couchbase client processes, and as well as non-frequent cluster topology changes, which makes it perfect for caching the client configuration. And that's exactly what the client configuration cache is. So the client configuration cache in Couchbase caches client configurations, including passwords, on the client side. And this is typically stored on the local disk on the client as a named file. And for PHP, it is configured, for example, in the ini file variable as follows. Definitely caching is a good thing, but at the same time, you need to make sure that the cache data that is cached on the client side is not world readable or writable. So there could be sensitive information in this that you may want to make sure that you protect and make sure that the world cannot read that. Only the respective process gets access to that particular path. There is also this concept of validating user input, which is a best practice. This has been, it's not something new. We all know about this. Don't accept an input from the user directly and maybe concatenate strings and basically send it to your database. So what you can see in an example, and I will kind of quickly demo it shortly, is where you see this JSON document, and the first part, the first password field, is the intended value. So the application was supposed to store a hashed value for that particular password field. But what happened is this application developer kind of concatenated these two fields, and they concatenated the first part as well as built maybe a concatenation based on a user specified input, in which case the last password and with a plain text password is the concatenated input. So if you try to save this document in Couchbase, what you'll be able to see is you'll be able to override the first field with the later supplied value. And let's take a quick look at this in a quick demo on this. Okay, so what I have here is a sample document. This is kind of a Python IDE here. So just this is a sample JSON document, and what you can see here is the first name, intended first name is Matt, but the attacker has kind of created a first name and wants to change that to Don. And so let's try this in Couchbase. So if you would kind of just. So here in Couchbase, I have a customer data bucket. And this customer data bucket has a bunch of different customer-related documents, which are, think of them as like customer-related user profiles, for example, in your app. And if I want, let's say we create a document and call this. Okay. So before I save this, just want to make sure everything is good. You have the first name, Matt, and which we think will get overridden by the first name, Don. So let's go and save this one. And let's make sure we see that on the screen, but let's make sure that's the case. So as you saw here is that field got overwritten by the new value. So going back to the presentation, what you can do with this is an attacker can inject arbitrary key value pairs. I just showed you an example where an attacker could kind of override a key value pair. They could also change specific document types. So for example, if you have a bucket and you have multiple document types, you can also override the document types. And for example, many apps, for example, maybe setting types, for example, private types or public, where a private type would be kind of not shown in the UI, whereas a public type would be shown in the UI. But doing something like this, you can kind of override that type. You can also override other important document fields. So one of the way in which you can work around this is in your Java and as well as .NET client libraries use like strongly typed POJOs and POCOs in these libraries. So you explicitly override the field. So it's not where you are kind of the attacker implicitly overrides and you're not aware of it. In the new model, by using Java POJOs and POCOs, you actually know when you're kind of overriding that field explicitly. Okay, so another feature that we added in 3.0 is Ssl support. And so what this feature is you have a bunch of clients, you have the server, and you want to enable an SSL connection between these clients and server. And this can be set up on a per bucket basis. A quick snippet on how this can be set up in the Java SDK as a part of the bootstrap of Java, where you just set the SSL enabled flag to true, specify maybe the local key store file, and the client is able to communicate with the server over SSL. Definitely, you need to set up some client certificates prior to this, so that the client knows what certificates to use as a part of this SSL connection. There's also client-side field encryption that you can do. So this is using third-party crypto libraries to encrypt and decrypt your data. So let's say you have the customer document, as we saw. There may be fields, for example, like credit card numbers within the document. You may want to just encrypt that particular field. And by doing something like this, by using some third-party client libraries, only the application would have access to the crypto keys. Couchbase does not have access to the crypto keys, and only you can ensure that your client only encrypts certain sensitive fields in JSON. So let me show you a quick demo on how some of this can be done in Python. So what I have here is I'm going to go back to my customer bucket. I'm going to just drop this document for now. So again, these are about 1,000 customer records. Let's open one of them and see how it is. So for example, for this customer, you can see that we have the card type, you have the card number, you have the card expiry date. Many of these fields are very sensitive fields, and you don't want to leave them in plain text. So one thing that you can do from an application perspective is, in this case, simple Python app where I access the bucket password. So again, remember, this is the password so that I can read and write from the bucket. I have stored, prior to this demo, I had actually stored this password in my keyring, so I don't really leave it in plain text in my app. I then open a connection to Couchbase with that password. I also read a crypt key password, a key that I want to encrypt my data with from the keyring. And then I loop over all my records, and basically, I have the card number printed here, but I also, let me just comment out this particular line here. Basically, what I'm doing is I want to encrypt all my credit card information, and then I'm doing a set operation. So let us run this. So let's go back to our app. Let's see. Okay, so we ran an app, and then we noticed that we are able to encrypt the credit card number field. So in this case, just remember, the client is the only entity that has access to this crypto key. Even if somebody steals this document, they do not know how to decrypt this key because this field, because they don't have access to the key. Now let's just go back and decrypt this document. Simple approach here. Just going to rerun it again. Okay, so I'm calling my decryption routine. And let's just refresh this document here. And you can see that the card number is back to its original card number.
Which breaks all your indexing.
That's an interesting question. So let's go back to our presentation. So couple of things to watch for. Indexing is definitely one of the things to watch for, but you may not want to index those fields which are absolutely not necessary. Because in this case, when you kind of have applied a cipher to that plain text, it's all gibberish, and your indexer doesn't understand what it is. But there's a couple of things you can do there. If you're, for example, doing equality searches through your index, you can keep hashes of the data. So along with have an additional field where you keep a hash of that particular encrypted data, and then you can do equality searches based on that hash. Yes, you lose the ability to do range kind of, something like where you can set like a start and end key range. You lose that ability, but you still have the ability to do equality searches for your data. There is, the other good thing here is you don't, please don't store your, crypto key along with the encrypted document, because then an attacker could just read off the key and basically decrypt that particular field. So make sure that your key is kept either on the client or, with some technology like, an HSM or, where you can tie your client with. So couple of things that you can do on the cloud. So we saw, things that you can do outside Couchbase, inside Couchbase, within your app, and a couple of things that you can do on the cloud now. So I'm going to focus on, running, for example, Couchbase on Amazon. There's a couple of things you can do on Amazon. For example, at the host operating system level, you can, set up individual SSH keys using Bastion host. You can make sure that all your accesses to your instances on Amazon are logged and audited through Amazon's logging capabilities. You can, at the guest operating system on Amazon, you have guarantees that AWS admins cannot log in to get access to that data. You can also do things like customer-generated key pairs. Firewalls, again, we talked a little bit on the firewall rules. There's a couple of things you can do on Amazon, like setting out the outbound instance firewall in VPC, or also using VPS in subnet ACLs. And finally, if you're managing your system on Amazon, you might want to maybe also sign your calls that you do to Amazon using a certificate or a customer key on Amazon to protect your access. So a couple of more things. So another feature that we added in 2.5 is secure cross-data center replication. And secure cross-data center replication enables you to encrypt your traffic between two data centers, using an SSL connection. So all traffic between the source and destination data center is encrypted, and there's a way in which you can periodically rotate your XDCR certificates, just hitting the regenerate button and making sure that you instantiate the new certificate on the remote cluster. There might be a slight CPU load because obviously any encryption needs extra CPU cycles. So through our internal testing, we've seen an slight increase in CPU load on the source as well as the destination clusters when you're using secure cross data center replication. So how do things look on the wire? I'm going to show you a demo shortly, but I haven't. This is like a screenshot, for example, from Wireshark, since we wouldn't be able to configure Wireshark today. But if you really look at the data that is passed between the wire between the two clusters, you'll see that this data is is kind of not readable. It is kind of encrypted, as you can see below. So let us quickly, take a look at an XDCR demo here. Okay, so here I have two clusters. So this is cluster 1, and this is cluster 2. So I have two clusters in two different regions. Let me try to set up XDCR. So I'm going to go to the XDCR tab on the source cluster. I'm going to set up a cluster reference, so you can do that here. I'm going to type in remote cluster. I'm going to pass in the remote cluster IP. So give me 1 second here. Okay. And then I'm going to hit this button called enable encryption. So the moment I hit that button, I am asked to kind of copy the remote cluster XDCR certificate here. So what I'm going to do is go to the remote cluster, go to settings. I'm going to, under the certificate tab, there is a link called show certificate. Show it here. I'm going to copy the certificate here, go back to my host cluster, and save it. So here I've set up a remote cluster reference that is SSL enabled. I'm now going to create, do some kind of replication between these clusters. So let me take a look at the source cluster. We have a bucket called beer sample. Let us go to our destination cluster. We have a bucket called beer backup. But let me create a new bucket here and call this sample destination. It's a Couchbase cluster. I'm going to leave the RAM quota as is, and I'm going to create this bucket. So we have created a remote sample destination bucket, and I'm going to go back to my source cluster now, and I'm going to go to my XDCR tab. I'm going to do replication. I'm going to select the remote, the source bucket, beer sample, and I'm going to say sample destination. So this is, I'm creating a one-way replication from my source cluster to my destination cluster. So this the contents in this bucket are going to get XDCR to this bucket, to the sample destination bucket over SSL. And if I hit the replicate button here, we see that replication is starting up. Okay, and you can see that now we're getting some documents in the sample destination cluster. So if you really had to look on the wire, while the replication was happening, you'll be able to see with Wireshark that the traffic is encrypted between these two clusters. So now for the exciting part, what's next? So we've added, couple of exciting features in all our releases. So in every single release, we've kept on adding more and more security features. And with 3.0, we talked about encrypted client-server communication. We talked about the admin access. We talked about the access log, and we talked about data at rest encryption, which you'll hear after the session through our partner Warmetric. So after 3.0. Things like preventive, detective, as well as administrative security controls in Couchbase is where we're going towards. And things along that roadmap are things like auditing, external authentication, users' roles, permissions, fine-grained auth, enhanced crypto, and more. So these are things that which you will see in multiple releases post 3.0. So don't forget, since we're all here to talk about 3.0, that you can download 3.0, try out some of the exciting security features that we added to 3.0, and the link to get there is couchbase.com/download. And if you have any questions now, I can definitely take them. Yeah.
Anything related to auditing, if you can describe further what kind of user level access and access to the bucket, is that part of the auditing?
I believe the question is about post 3.0. So it's very early in our plans right now. I can't talk about the level of or the detail or the granularity of auditing that we might think about adding in.
Okay. Any plans to do a serverization?
External auth is definitely along those lines. Things like LDAP, Kerberos protocols, things like that are definitely considered. Yeah.
The CLI takes a lot of password on the command line, which isn't too secure. Is there anything to fix that?
Not on top of my head as of yet.
Currently today, you can set for trusted CLI in 3.0.
Okay. Yep.
You don't have SSL in 2.0, how is the password sent over the wire? Is it encrypted at all?
So passwords, at least if you're using CRAM MD5, they're definitely not in plain text, right? But you can do SSL in 2.0, not out of the box, but something that I talked a little bit on IPsec, where you kind of just secure your infrastructure at the network level, so that all kind of communication at the network level is over SSL. So you can do that. Yeah. Yep.
How much of what we just saw was only for the enterprise?
So if I get the question right, which features are enterprise? Or?
But is SSL going to be available
It is only for the Enterprise Edition today. Yep. Yes.
So you mentioned that you support HTTPS for admin access now.
Yes.
So, but what happens? So when you enable admin access, then is HTTP still open the port, or can you configure it to?
Yeah. So port 8091 is still open. Port 18091 is also open, one of them being SSL and one of them not being SSL. One idea there is you may have buckets, for example, which need SSL. There are buckets which may not need SSL. So you can use, like there are applications which say, hey, I want to use SSL. The clients have to go over SSL. There are apps which say, I'm okay to communicate with the bucket without using SSL. So that's why we leave it open. But however, if you want to force SSL in your environment, you can set up firewall rules to make sure that you go only over SSL.
I think it might make sense to make it configurable to just explicitly shut it off
Mm-hmm.
and not rely on ACL for more open.
Okay, that's definitely valuable feedback. Thanks. Yeah.
8091 is only for management ports, right? Not for the data part.
That's correct. Yeah.
So if you are like putting a jump host and you're like Couchbase inside the data center, so what left is just the data part, which is still plain text and of communication the client to the Couchbase.
Correct. So the list of ports that I went through covers also the data ports. So you can secure those particular data ports based on your firewall rules at that level of firewalling. So you can ensure that only respective entities get access to it.